Hello friends, today I will solve a LeetCode medium problem on arrays. So the problem says, given an integer array nums and an integer k, return the number of non-empty subarrays that have a sum divisible by k. And a subarray is a contiguous part of an array. So we are given a array nums and an integer k. We need to find the number of subarrays whose sum is divisible by k. So in the first example, you can see we are given a nums array of size 6 and k equal to 5, and you can see there are 7 subarrays with sum divisible by 5. So we know that there will be n into n plus 1 by 2 subarrays. So the brute force approach will be run two nested loops and consider each subarray, and for each subarray compute the sum and check if it is divisible by k. If the sum is divisible by k, increment the result variable, and at the end return the result. So this is not the optimal approach. So now I will discuss the optimal approach with the help of this example. So I have taken the first example. So I will solve this problem using prefix sum and hashing. So the idea is, let's say the sum from index 0 to index I is A, and the sum from index 0 to index j is B. Let's say A mod k equal to x and B mod k equal to x. So in this case, we can write A equal to sum p times k plus x, and we can write B as q times k plus x. So p will be A by k and q will be B by k. If we write B minus A, then it will be q into k plus x minus p into k plus x. That will be q minus p into. So we can say the b minus a corresponds to the sum from index I plus 1 till j. And we can see this is a multiple of k. So we have a subarray from index I plus 1 till j whose sum is multiple of k. So I will use this idea to solve this problem. So first I'll declare a result variable. I result will be 0. Then I'll declare another variable called prefix sum that will be initially set to 0. Now I'll declare an map from integer to integer. So initially the map will contain the mapping from key 0 to value 1. So I'll discuss why it is required. So it is required to count all the prefixes that start from index 0. So it will be clear when I'll go through the example. So I'll start from the index 0. So the prefix sum will be 0 plus 4, that will be 4. Now I'll check remainder equal to 4 mod k, that is 5. It will be 4. So in the prefix map, I'll check for this remainder. So I can see there are no key with value 4. So I can say there are no subarrays ending with index 0 which are divisible by k. Now in the prefix map, I'll store this remainder. So I'll insert a pair 4, 1 into the prefix map. Now I'll go to next index, that is I equal to 1. So here I'll update the prefix sum to 4 plus 5, 9. And I'll compute the remainder 9 mod 5, that will be 4. I'll then check the prefix map. I can see there is an entry for key 4. So using the idea I described here, I can say there is a prefix that ends with index I and whose sum is divisible by 5. So I'll increment the result variable to 1. For example, I know that for this subarray the sum is 4 and for this subarray the sum is 9. So I can say for this subarray the sum will be 9 minus 5, 9 minus 4, that is 5. So I can say this subarray of size 1 is divisible by 5. Now I will insert this remainder into the prefix map. I can see an entry for key 4 already exists. So I will increment its value to 2. Next I will go to next index I equal to 2. So here prefix sum remains same, that is 9 plus 0 becomes 9. I will compute remainder here, that is 4. So I'll check for 4 in the prefix map. I can see the 4 is already present and its value is 2. So we know that before this index there were two indexes where remainder was 4. So I know that if I compute the sum from those indexes till this index, the sum will be divisible by k. So if I consider the subarrays from index 1 to index 2, it has a sum 5, and from index 2 to index 2 it has a sum 0. So these two subarrays are divisible by k. So I will add 2 to the result variable. So now the result will be 3. So I will update the count of 4 in the prefix map to 3. Now I will go to next index, that is I equal to 3. Then I will update the prefix sum to 9 minus 2, that is 7. I will compute the remainder, 7 mod 5 equal to 2. So I'll check for 2 in the prefix map. So there are no mapping for 2. So I can say no subarray ending with index 3 is divisible by 5. Then I will insert 2 to the prefix map with value 1. Then I'll go to next index. Then I will become 4. Then I'll update the prefix sum to 7 minus 3, that is 4. Then the remainder will be 4 mod 5, that will be 4. So I'll check in the prefix map. I can see for 4 the value is 3. So the pairs starting from index 1 to index 4, then another pair starting from index 2 to 4, then another pair starting from index 3 to 4. So all these pairs, so for 1 to 4 the value will be 5 minus 2 minus 3, that is 0. For 2 to 4 the value will be 0 minus 2 minus 3, that is minus 5. From 3 to 4 the value will be minus 2 minus 3, that is minus 5. So all these three pairs are divisible by 5. So I'll add 3 to the result variable. So now the result will be 6. And I will update the value of 4 to 4. So I will basically increment the value of 4 to 4. Then I'll go to next index I equal to 5. Here I'll update the prefix sum to 5. Now I'll compute the remainder, that is 5 mod 5, and that will be 0. So I'll check in the prefix map. I can see there is a mapping for key 0. So I'll consider its value. So this is the reason we are inserting the mapping. So we are inserting the pair 0 1 in the prefix map initially. So it means the subarray is starting from index 0. So if I consider the subarray from 0 to 5, the sum will be 4 plus 5 9, minus 2 7, minus 3 4, plus 1 5. So the sum is 5, which is divisible by 5. So I'll add value 1 to the result. So the result will be 7. Then I'll increment the value of 0 to 2 in the prefix map. So for each index, what we are doing, first we are computing the prefix sum, or we are updating the prefix sum, then finding the remainder, then checking for that remainder in the prefix map. So if there is an entry for that remainder present in the prefix map, we will add its value to the result variable. Then I will update that remainder's value in the prefix map. So in each step, we are doing constant number of operations. And if we use prefix map as hash map, so the time for lookup and insert in the map will be big O of n. So we can say the time complexity will be big O of n. And we are using a prefix map. So at the worst case, let's say all the remainders are different. So it will contain an entry for each remainder. So the space will be big O of n. So now I'll code the solution. So first I'll declare an result variable that is set to 0. Then I'll declare prefix sum that is set to 0. Then I'll declare the prefix map that will be a hash map. Then in the prefix map, I'll insert the pair 0, 1. So this is required to count the subarrays that are starting from index 0. Then for each num in the nums array, first I'll update the prefix sum. So I'll add num to the prefix sum. Then I'll compute the remainder that will be prefix sum mod k. So as the numbers can be negative, so the prefix sum can go negative. So if remainder is less than 0, so I'll add k to the remainder to make it positive. Then I'll check if the remainder is present in the prefix map. Then I'll add that value to the result. Then I'll increment the value of remainder by 1 in the prefix map. Else, if the map doesn't contain remainder, I will insert the remainder with value 1, and I will not update the result variable. Then at the end, I will return the result. So let's run it for the sample test cases. So the sample test cases are running fine. Now I will submit it. So you can see it's working as expected. Thank you.